Today, we're diving into the fascinating world of Uranus's third largest moon, Umbriel. Discovered in 1851 by William Lassell, it shares its discovery day with its sister moon, Ariel. Let's begin by discussing the unique aspects of Umbriel's orbit. This moon is tidally locked to Uranus, right?
Exactly. Umbriel is indeed tidally locked. This means, like our moon with Earth, the same side of Umbriel always faces Uranus. Its orbit lies completely within Uranus's magnetosphere, which significantly influences the surface by exposing it to charged particles.
Interesting. The magnetosphere's effects on Umbriel's surface must be quite pronounced. The moon's surface is actually the darkest among Uranian moons. What gives it that distinct appearance?
The darkness is largely due to the moon's heavily cratered and ancient surface. Impact craters have shaped it, and bombardment by magnetospheric particles may have enhanced this darkening by affecting the icy surface. This bombardment decomposes methane trapped in ice, darkening the material.
And those impacts resulted in quite a few craters, the most notable one being the Wunda crater. It has a distinct bright ring, which is quite unusual, isn't it?
Yes, the bright material in Wunda's crater might be impact ejecta, but it's also possible it's a deposit of pure carbon dioxide ice. This contrasts with the otherwise uniformly dark surface, a feature that's yet to be fully understood.
Speaking of surface features, Umbriel doesn't show as much geological activity compared to, say, Ariel or Titania, right?
Correct. Compared to its counterparts, Umbriel appears geologically inactive. While there are canyons suggesting some tectonic activity, it appears to have stabilized relatively early in its history, especially post the late heavy bombardment period.
I read that Umbriel might have had early endogenic resurfacing activity. What does that mean for its evolutionary history?
The early endogenic activity could mean that, initially, parts of its surface might have been reshaped by internal processes rather than impacts alone. However, much of its crust has likely remained unchanged for billions of years, preserving those ancient features.
That's fascinating. Let's move to its composition. Umbriel is differentiated into a rocky core and icy mantle.
Indeed. The moon's density suggests a mix of rock and ice, with an approximate 60-40 distribution favoring ice. The presence of water ice crystals on its surface is confirmed by spectroscopic observations, which support this composition.
And there's also carbon dioxide detected on the surface. Its distribution is asymmetrical. What could be the reason?
The CO2 is more prominent on the trailing hemisphere, likely due to magnetospheric interactions, leading to its localized production or the outgassing of primordial CO2 from the interior. This adds another layer of complexity to Umbriel's geological story.
With its discovery dating back to 1851, have any significant explorations provided close-up data on Umbriel?
Voyager 2's flyby in 1986 remains our best source of close-up images. Although the spacecraft managed to capture only about 40% of Umbriel's surface, the data collected was pivotal in mapping those regions, albeit with limited geological detail.
Such missions, despite their limitations, significantly enhance our understanding. As exploration technology advances, perhaps we'll uncover more about Umbriel and its enigmatic features.
Absolutely. Future missions might shed light on these mysteries. Each discovery provides us with a more nuanced understanding of not just Umbriel, but also the dynamic environment of Uranus and its satellite system.